In example 3, they want us to find antiderivatives, and they tell us we can use guess and check here. So again, for my constant of integration, instead of putting in a specific number, we're just going to use the capital letter C. And so I also want to practice some of my notation. And so when I find the antiderivative of f of x, I am looking for capital F of x. And let's see. So what would happen if I took the derivative? What do I take the derivative of and get a constant? So that would be maybe 8x. And if I take the derivative of 8x, this is x to the first power, so 1 times 8 is 8 times x to the 0, power times base down 1, x to the 0 is 1, so I just get 8. And so we would have f of x equals 8 plus x plus c. What about g of x? So g, capital G of x, the antiderivative is going to be, and remember that when I undo the power rule, I want to raise the exponent by 1 and then divide by the exponent. So this would give me 3/2 x squared and then plus c. Now let's just try and see if that works. So 2 times 3/2, the 2's cancel, giving me a 3, and then power times base, and then down 1, reducing the 2 to a 1, that leaves us with an x, and of course the derivative of the constant is 0. So it checks out. In part C, we have f of t, capital F of t is going to be equal to, and so this would be raise the exponent by 1, so 2 becomes a 3, and now I want to divide by the 3 and add a constant. And then if I take the derivative back to see if we get what we started with, power times base down 1, 3 times t squared over 3, the 3's cancel, leaving me with t squared, and again the derivative of a constant is 0. And then in part D, we have f of theta equals cosine theta. And so what do I take the derivative of to get cosine? And so if you think back through the derivatives for your trig functions, hopefully you may remember that the derivative of sine is cosine. And so our antiderivative would be sine theta plus c. Let's do a couple. In part E, they give us g of t is equal to the square root of t. Now I find that it is helpful to rewrite your roots with rational exponents, and so this would become t to the 1/2. And so let's find what g of t is. Alright, so again, undoing the power rule, I would need to raise this by 1. Okay, so the question is, what is 1/2 plus 1? So 1, you could think of that as 2/2, and so if I increased 1/2 plus 2/2, I would get t to the 3/2. And then remember that we divide by the exponent. So divided by 3/2 plus c. And so if I simplify this, g of t is going to be equal to 2/3 t to the 3/2 plus c. Now let's take the derivative and see if we get what we started with. So 3/2 times 2/3 completely cancels. And then power times base down 1. If you subtract 2/2 from 3/2, you get t to the 1/2. And then of course the derivative of c is going to be 0. In part F, we have h of t is equal to 1 over t. And again, I am going to rewrite this now using a negative exponent. So we have t to the negative 1. And so h of t, and we might be tempted to look at this and apply the power rule. And if we do this, we get t to the 0 power. And that's a constant, but I know if we took the derivative of a constant, we would get 0. We wouldn't get 1 over t, so that can't be right. All right, so now I've got to think, what in the world could this be? So can you think of a function whose derivative is 1 over x, or 1 over t? So if you think back through your rules for derivatives, or if you look back through one of our flip charts, hopefully you managed to come up with the natural log. And so this is going to be ln. And you know what? We want to make sure we assume the domain of h is going to be all real numbers except 0. They didn't tell us what the domain was. So, I mean, I have to assume that the only value that would cause a problem here is going to be 0, and so t not equal to 0. So that means that t can be negative. So to handle that, I can't take the natural log of a negative number, so I'm going to need to put this in absolute values. So now the derivative of the natural log of the absolute value of t is going to give me 1 over t. And in that case, t could be positive or negative. Let's look at g. In g, they give us r of t is equal to 1 over t squared. And I think I'm back on track now with my polynomial. So I'm going to rewrite this as t to the negative 2. And so that means that r of t is going to be equal to, and if we add 1 to this, we get t to the negative 1. And we want to divide by negative 1 plus c. And so we get r of t is equal to negative 1 over t plus c. Now if we differentiate this, we could rewrite this as negative t to the negative 1. Negative times negative is a positive. Power times base down 1, negative 1 goes down to negative 2, and this becomes t to the negative 2, or 1 over t squared. And then finally in part h, let's just go ahead and do x to the negative 3. And now we can differentiate, or find the antiderivative, anti-differentiate. And so raising this up 1, we get x to the negative 2. But of course we want to divide by negative 2. And let's check and see if this works. So if we did power times base down 1, negative 2 times x to the negative 3 over negative 2, the negative 2's cancel, we get x to the negative 3, which is 1 over x cubed. So it works. So let's rewrite this as negative 1/2, or actually negative 1 over 2x squared. We'll just go ahead and get rid of the negative exponents and move that down to the bottom.